All right, 9.2 is finding the roots and the vertex. So what we talked about in 9.1 was just the general form for quadratics. Just do a little bit of a review here. If I can get my notepad to work. All right, we did standard form. We said all equations of a parabola are going to look like this. Y equals ax squared plus bx plus c. We talked about how this is kind of like our general linear form for y equals mx plus b. That's just if this part was gone, right? If we just have this part gone, we would just have bx plus c. So this is kind of our general form for a quadratic, and that always turns out to be a parabola. Okay, might be going up and down, might be going this way, and what we talked about in the previous chapter was the point where it changes directions is called the vertex. And so we're going to practice finding the vertex for different ones, maybe where on a graph where it's not as apparent just from the graph where the vertex is. So you need to know what this word is, what roots means. Just like you had to learn the vocabulary of slope and y-intercept when you were doing linear equations, this is just one of the terms that goes along with all quadratic functions. They are going to have roots. And the solutions to a quadratic function where f of x equals 0 are called the roots. So remember that f of x really just means y. So we're just really trying to find out when y is going to equal 0. And that is on a graph the x-intercepts. So if you think about a graph of a parabola, right, when y equals 0, that's going to be right along the x-axis. So that's these two spots. Those are called the roots. And so it says, how do I find the vertex if I have the roots? I've just got these two steps. I want you to jot them down. We're going to go through it in a minute. But step 1 is going to be to use the line of symmetry to find x. Okay? And then step 2 is going to be to use your equation and the x value, and that would have been from step 1, okay, to find the y. So let's look at a specific example. Here's a parabola. We want to look for the roots and the vertex. These are going to help us write equations for parabolas. Okay? So the roots, like I said before, are where y equals 0, or they're the x-intercepts. Okay, so that would be 2 and 8. So our roots are 2 and 8. All right, and then we want to figure out our vertex. So what I was saying before was that we want to use the line of symmetry. So the line of symmetry is going to be exactly in between our two roots. So between 2 and 8. So I want to average those numbers. So I want to look at what would be halfway between those. Okay, so 2 plus 8 divided by 2. That's going to be averaging those two numbers. And that gives me 5. 5 is halfway between there. Okay, so that would be my line of symmetry. It's going to be down where x equals 5. That's my line of symmetry. So I know my vertex is going to be right on there. Okay? And then what we're going to be able to do later is we're going to be able to, we know that x equals 5. Okay? And when you have your equation, okay, which we don't have yet, you're going to be able to plug in x equals 5. So for example, if this was y equals, I don't know, x squared plus 2x plus 6, which it's not, but if that's what it was, I would just take and put 5 in for each of the x values, and that would find me my y, and I could tell you what the y value was at that point. I could tell you exactly where my vertex was. So, but for this one, we're just going to go ahead and we're going to kind of use our estimating skills. If I look over here, it looks like it's halfway between -8 and -10, so it looks like my vertex is going to be at 5, -9. Alright, and then the last step is going to be to look at the general form, or a different form other than the general form for the equation. This is called vertex form, and that's where the vertex really comes in handy. It's in this form, y equals a times x minus h squared plus k. A is the scale factor. We've talked about that before. That means if it's being stretched or if it's being shrunk, and if it's negative, you know that it's reflected then over that x-axis. If it's positive, you know that it's just an upwards facing parabola. And then where HK is the vertex. Okay, so let's go back to that last example and let's go ahead and find the equation using this form. So y equals a times x minus h squared plus k. Well, I want to see if I think my parabola has been stretched or shrunk at all. And what I'm going to do is I'm going to look at some different points. So as I go over 1, is it going up 1? And as I go over 2, so from 5 to 3, is it going up 4? And it looks like it is, okay? So that means that our scale factor it's not changing at all. It's an upward facing parabola. It's not being stretched or shrunk, so we're not going to have to put anything in for a. It would just be kind of like a 1. So y equals, I'm going to go ahead and put that 1 in there for now, 1 times, and then x minus, and then we're going to do h. Oops, wrong way. So our vertex is 5, negative 9. This is a little bit of a preview. I don't think you're going to have to do this on your homework, but we're just going to go ahead and show you a little bit. Y equals 1 times x minus 5 squared plus k, which is negative 9. So hk is our vertex. So this is h, this is k. H is the x value, k is the y value of your vertex. All right, and so then getting rid of that 1 here, get rid of that, because 1 times anything is just itself. I don't really need it in there. I get my equation right here. Y equals x minus 5 squared plus negative 9. Okay? All right. So I'm going to do example A. I'm going to look at this graph here. I'm going to use the graph to approximate the roots and the vertex of y equals x squared minus 5x minus 6. So here's my equation. So first thing I'm going to do is get my roots. Okay, so right here and right here. So if I count 1, 2, 3, 4, 5, 6, my roots are 6 and negative 1. Okay, got negative 1 and 6 right here for my roots. So I want to go ahead and average those to find out the middle. 6 plus negative 1 divided by 2 would give me 2.5, right in the middle there, right? So let's just make sure 2.5, that would be right in the middle. It's 3.5 away from this one, 3.5 away from this one. So 2.5 is my line of symmetry, which means that my vertex is going to be right at 2.5 for my x. So if I'm talking about my vertex, the x value is 2.5. Oops, 2.5. I want to find the y value. So this is what I was talking about. We're going to use our equation to go back up and find our y. So we know that we get y. We know that we get y by taking this function right here. So we're going to take x, 2.5 squared minus 5 times 2.5 minus 6. Basically, anywhere there was an x in our original equation, I'm replacing it with a 2.5 to find the y value at x equals 2.5. Okay? So if I type that into my calculator, I haven't done that yet. Let's just look. I'm going to do 2.5 squared minus 5 times 2.5 minus 6. I'm going to get y equals negative 12.25. So if I go to my line right here, it looks about right. This is going by 2s, 2, 4, 6, 8, 10, 12. So it must be a little bit below that 12. So good thing that I used my equation to help me find the exact value. All right, so I've got my vertex, I've got my roots, and I'm done. What I want you to try is to do that exact same thing for the next example. So you've got your equation, you've got your graph. I want you to try and approximate the roots and the vertex for that graph and bring that to class tomorrow.